In this video, we'll be solving applications using right-angled trigonometry. These are some of my favorite problems in trig. A lot of with trig, we're learning new stuff and we're practicing skills, but I really like the application problems because then we're actually doing something with these skills that we're learning. So our general approach, our steps to solving an applied trigonometry problem is you want to start with a sketch. This is really important for us. Make sure that we have all our angles in the right spot. So draw a sketch and label it with the given information. Label the quantity to be found with a variable. Then you're going to use the sketch and our definitions of our trig functions using SOHCAHTOA to write an equation relating the given quantities to the variable, and then we'll solve our equation and check that our answer makes sense and include any necessary units since this is an application problem. To find the distance RS across a lake, a surveyor lays off side RT to be equal to 53.1 meters, with angle T being 32 degrees 10 minutes and angle S being 57 degrees 50 minutes. We want to find the length of RS and we'll round our answer to the nearest hundredth. Although my picture looks like there's a right angle there, there is no proof by picture, and you're going to find your diagrams they're not always to scale. So we have to prove that there is a right angle before we can use our right angle trig definition. So we were told that our side RT is 53.1 meters. We were told that our angle T is 32 degrees 10 minutes, and our angle S is 57 degrees 50 minutes. But like I said, we have to prove that angle R is a right angle. So how can we do that? Well, if angles S and T add up to be 90, it's going to force angle R to be 90. So you'll notice that the measure of angle S plus the measure of angle T does indeed equal 90 degrees, so we can conclude that angle R is a right angle. But you can't just assume that. You always have to prove it. And on a test or something like that, I'm going to want to see something that shows that you proved that you had a 90-degree angle there. Okay, great. We got our 90 degree. We're trying to find the length RS. That's this over here. And we want to use one of our trig functions and SOHCAHTOA. If I use angle T as my reference angle, side X is opposite and side RT is adjacent. Oh, opposite and adjacent, that is our tangent function. So we can say that tangent of 32 degrees 10 minutes is equal to our opposite side, x, over our adjacent side, 53.1. And now we solve for x. Multiplying both sides by 53.1, we get x to be equal to 53.1 times tangent of 32 degrees 10 minutes. And now we just need to plug that into our calculator and round to the nearest hundredth. Make sure you are in degree mode. And we get x to be 32.40, and our unit is meters. Next, we want to find the altitude of an isosceles triangle having base 184.2 centimeters if the angle opposite the base is 68.73 degrees. We'll round our answer to the nearest hundredth. Well, the first thing I would do is I would draw an isosceles triangle. Remember that an isosceles triangle has two sides that are the same. So it's going to be these two sides that are the same. Says that the base of this isosceles triangle is 184.2 centimeters, and our angle across from that 68.73 degrees. We want to find the altitude. So now we have to go back to geometry and remember what the altitude is. The altitude is the height of the triangle, so it would be this right here. And with an isosceles triangle, the altitude, when you drop it, makes a 90-degree angle with the base. A couple other things that are unique to the altitude of an isosceles triangle. The altitude is going to cut the base perfectly in half. So this half is going to be 92.1, and it also cuts the angle opposite the base perfectly in half. So it's going to make this angle 34.365 degrees. And what we're trying to do now is find the height here, the altitude. Okay, I'm going to draw a breakout triangle because I feel like my diagram's complicated looking. So I like to draw breakout triangles that just includes the information I need to focus on. So I've got a right angle with a base of 92.1, an angle of 34.365 degrees, and I'm trying to find this side x. Now we want to use one of our three basic trig functions to relate this one angle and two sides. So from our angle 34.365 degrees, we have the side that is opposite and the side that is adjacent. So opposite and adjacent tells us that we want to use tangent. Tangent of 34.365 degrees is equal to 92.1 over x. And we want to solve for x. X is currently in the denominator, so we'll multiply both sides by x to get it out of the denominator. That gives us x times tangent of 34.365 degrees is equal to 92.1. And then lastly, we're going to divide by that tangent. This gives us x equals 92.1 divided by tangent of 34.365 degrees. We'll put that into our calculator and round to the nearest hundredth. That gives us that x is equal to 134.69, and our unit is centimeters.